Hello students, welcome back. Module 5 is a continuation of Module 4. We are still in differentiation, but this time we are going to be dealing with a little bit more complicated functions. Composite functions, namely. Now this module deals with a topic which is basically make or break for entire semester. Not only it is the most important topic in entire Calculus 1, I mean the chain rule, but also it generates the most mistake. So if you are mistake prone, then you have to pay particular attention here. Okay, here we go. Let's begin with a review. This is a definition of the derivative, the Newton quotient, f of x plus h minus f of x, which is basically rise, the difference of y coordinate, over h, which is run, the difference of x coordinate. Taking a limit, you have instantaneous rate of change, or the slope of tangent line. Some trivial rules: the derivative of constant is 0. Yes, derivative of horizontal line is 0. The slope of horizontal line is 0. And then addition or multiplication by coefficient, you can take the derivative either before or after. How about the product of two functions? Can you take the derivative either before or after multiplication? You can't. You get two different situations here. Derivative of the product is not the product of the derivative, but this one, u prime v plus uv prime. Be careful here, the product rule. And the quotient rule. Some known derivative formulae, the power function, the exponential function, and the logarithmic function. If you have general base, then you get ln of a and ln of a showing up kind of like this. If necessary, you can look those up, but most of the time we're going to be dealing with natural exponential functions and natural logarithmic functions only, so please memorize these three. How about trigonometric functions? Sine and cosine, everybody has to memorize, yes, but the others, you can just write down in your formula sheet and bring those back, although I would much prefer that everybody memorize these as well. Okay, let's utilize all these for composite functions, and here we go. This is how the derivative formula for a composite function works. We're going to talk about why this is true in a separate video toward the end of this module. Right now, let's focus upon the structure and then an application problem. Structure goes like this. Step 1, outside first. So derivative of outside function first, that's blue. Step 2, inside stays the same. No change here, inside always the same. And then step 3, the derivative of the inside comes not here inside, but out here like a dangling chain. And because of this final part, this thing is called a chain rule. And that's a derivative for composite functions. Whenever you see a big parentheses, you have to think about the chain rule. And you may have to use chain rule multiple times in the same problem. Okay, let's go over to at least one problem here. And let me try to do it as slowly as possible. Here's a nice problem. A composite function, f of x is square root of this expression here. So f of x is basically equivalent to x squared plus 1 to the 1/2 power function. It's always better to have a power form than this traditional radical expression. And let's take the derivative. What's step 1? Derivative of the outer function first. And what's the outer function here? It's 1/2 power function. So that's step 1. Power comes out as coefficient. And let's subtract 1 from the power. That completes step 1. Outside first, and then we go in. Next, inside stays the same. X squared plus 1 comes here. It's not the derivative, stay the same. Let's go to step 3. Here comes the derivative of the inside. Like a dangling chain, we have to multiply. and that completes the problem. But if you simplify this, because this is 1/2 and that 2 cancel out, you're going to get x squared plus 1 to the negative 1/2 power, and I'll call that completed problem. Now let's go back and do some color coding here, because especially early on that really helps. The blue part is the derivative of the outer function, and then the red part inside stays the same, and then chain part green, and that is the structure of the chain rule. Now if you're interested, you can change the final form into a traditional notation as well, because negative power means it's denominator, and 1/2 power means it's the square root. It's a final transformation here. Is it really necessary? I do not think so, and I usually don't do that. I usually stop here at the power form. But our textbook author usually disagrees, and then our textbook author usually does this. But that's okay. In computer grading system, in WebAssign, both are considered as correct answers, so you don't have to kick yourself trying to simplify at the end. Once you are done with the derivative rules, it's okay. You can stop here. Let's do this once more. And again, I'll try to do this as slowly as possible as we did over here. By the way, the answer key is already posted here, so there is no reason to keep the duplicates. So let me remove this. And let's go over to the second problem. This is just as elementary problem in terms of the chain rule, but overall level of difficulty is a little bit higher because the initial step, the power form part, is a little bit more complicated. Well, number one, we have a coefficient. Here we didn't have any coefficient, but here we have coefficient 3, so okay, there you go. And then what's the outer function? Is it a fraction, or is that the square root function? Actually, it's neither. It is negative 5/2 power. Let's see, why negative? Because this whole thing is in denominator. That gives you negative sign. Now why 5th power? This one is 5th power. That gives you this 5. And finally, why this 1/2? 2 in denominator here. That's coming from this radical here. If this radical had been upstairs like a previous problem, then you have 1/2 power, but positive. But this time, negative. Okay, so much for the conversion, and let's apply the power rule here and the chain rule. The derivative, alright, coefficient 3 was there before, so no problem there. And what do you multiply? You multiply the power negative 5/2. See, by the power rule, power comes out as a coefficient, and subtracting 1 from the power, we get that. That completes step 1 of the chain rule. Outside first. Now let's go to the inside. And one of more common mistake is this, taking the derivative of the inside. But this is wrong. You see, inside always stays the same. So whatever here we have, just copy and paste. And that completes step 2. Now let's go over to step 3, the chain part. You have to multiply the derivative of the inside, which is 6x minus 2. Shall we do some color coding as before? Okay, let's go ahead and do that. Multiplying this. And then this power over here. That's step 1. Inside stays the same, and that's step 2. And finally, multiplying the derivative of the inside, like a dangling chain, the chain part. That's step 3. If you want to simplify, you can go ahead and simplify. I decided not to bother with simplification in this problem. If you want to see simplification, just go to this notebook and open up the answer key, and you'll see all the simplification here. Yeah, this 2 in denominator and these even numbers cancel each other out, and we get something more, something less complicated. But I don't know whether this is this is a kind of computation that is really worth it or not. I generally don't bother with simplification. Okay, we have one more motivational problem here down here, and we have sufficient time, so let's complete this. Let's move on to the next set of example in next video clip. Here, let's complete this problem. What's the derivative of this exponential function? Again, let me remind you of the chain rule, the step-by-step process. This is a formula, and then 1, 2, 3. Okay, exponential function always the same. So there you go, and inside always stay the same. So doubly staying the same, exponential stay the same, blue, and inside staying the same, red. So it's doubly staying the same. And then let's multiply the derivative of the inside, which is 6x plus 2, and that'll complete the problem. Sometimes when you have some small font, it's a little bit confusing what to multiply where. In that case, it's safer to put some multiple parentheses to make sure where the multiplication is being conducted down here. Let's see, this is now clear. We are multiplying exponential with 6x plus 2. Okay, so much for elementary problems, and let's meet again in the next video clip.